Hello everyone, I am Hunter Well, and this week we're going to be talking about file input and output and string processing. Alrighty then. So, uh, last week we talked about a little bit last about how there's different ways to get input for your programs. One was with the standard input device, the keyboard, and the other way is through files. And this week we're going to be learning about how to get that input through the files. Now, Um, if you want to prepare input data ahead, you may store the data in a file and direct the program to read its input from a file. If you want to save the output data in a file for later use, you may direct the program to write a file. To read and or write a file, do the following. So yeah, it's a four-step process. It's not actually as scary as you think it's going to be. So the first one is to include the file fstream, the preprocessor to include the file fstream as well as iostream. The fstream contains declarations for defining input and output streams with files other than C in and cout. So as you can see, what we do first here is do hash include iostream and hashtag include fstream. So fstream is what allows us to manipulate files. Now, we then declare an input stream to be of type iostream or an output stream to be of type ofstream. We don't need to have both. We can have one or the other depending on what we need. So in this example though, they're showing an input file and an output file. So we say iostream variable name is indata and then ofstream's variable name is outdata. So you can name this variable whatever you want. Make sure it's just something logical and makes sense, so if you ever come back to your program and need to read it again, you understand why you named it what you did. Right. So then step 3 is prepare the stream by using the function name open provided in the fstream. The parameter for the function open is the external name of the file. The external name is the name under which the file is stored on the disk. And then step 4 is put the eternal file name to the left of the insertion or extraction operator. Alright, so that sounds kind of complicated, but it's really quite simple. So what we do is we say indata.open inputfile.txt, and we put that inside of a double quotation mark, so that's our string. And then we say outdata.open outputfile.txt, and we put that inside double quotation marks, alright? So we need to make sure that our program has access to this input file and output file.txt. If your files are named something different, then you would put a different name here. So if my file's input name was ages, then I would say ages.txt instead. Okay? And then to start extracting the data from the input file and putting it into our program and storing it in these variables, what we do is we say the input variable in data, the extraction operator, value 1, value 2, value 3, value 4. And then we store it into our 4 inputs. And then to put those inputs into the output file, what we do is we say outdata value 4, 3, 2, and 1. Alright, we don't have to split it on 4 separate lines like they did here, but they're just showing that you could do it either way. And then we make sure we close the files just in case any other programs would like to access them. If we don't close the files, then the other programs won't be able to access them. So each file in your program has both an internal name and external name. The internal name is what you called it in your program. The external name is the name operating system knows it by. Okay. So somehow these two names must be associated with one another. This association is called binding and is done in the function open. Notice that indata and outdata are identifiers in the program. Inputfile.txt and outputfile.txt are character strings. Inputfile.txt is the name that was used when the input data file is created. Outputfile.txt is the name of the file where the answers are stored. So you can also create a data text file by selecting add new item to the project as a text file in Visual C++, for example. It looks like this, 5.5, 6.6, 7.7, 8.8. So I'll show you what it means by we can actually add the text file right into our program. So what you do is you go and you open up your Visual Studios. Click New Project, Windows 32 console application, do not create a directory for solution. Check off Empty Project and click Finish. what we'll do is we'll add our new item, a .cpp file, and I'm going to call my file IO. Okay, so we can come back to this website though and copy and paste this program. And now I'm going to add the text files. So it's expecting 4 inputs from our text file. So in my text file, I should have 4 numbers. What you do is click Project, Add New Item, Utility, Text File.txt. So the text file name it's looking for is input file.txt. And so I have to make sure I name mine input file.txt. So something neat though is when we do this outdata.open output file.txt, if the computer cannot find the output file, what it will do is it will create it for us. So we don't actually have to add an output file because the computer will create it on its own. So the numbers that they were looking for us to put in our text file though is 5.5, 6.6, 7.7, 8.8. Okay, something to keep in mind though is it's okay to have too much input in your text file. So if I were to keep going and say 9.9, 10.10, 11.11, and so on, this won't cause any problems when our program will run because our program will only grab the first 4 inputs. Afterwards though, it will just ignore it. Alright? If we had too little inputs though, then we would have a problem because the computer would be trying to grab data that isn't there. So you can have too much input, that's okay. Just make sure you don't have too little. So I'm going to run this program. What will happen though is when I run this program after I build it here, is you won't see your usual command terminal. Like the command terminal will pop up, but you won't see any output in it because we're not doing any cout or cin commands. So it's just going to output everything right to the file, and it looks like our program won't do much. So if I hit start without debugging, it just literally says press any key to continue. That's because we're putting all of our output to the output file. So how do I view this output file? What you can do is you can click Project, Add Existing Item, and then as you can see, it created the output file inside of our project. So if you double click on it, you'll add it in, and then you can see that the output is 8.8, 7.7, 6.6, 5.5, when our input was 5.5, 6.6, 7.7, and 8.8. We put it in reverse order. And I want you to keep in mind that your manipulators like endl that you use for your string operations also affect your out data. Okay, so that's file, input, and output. And on this next link though, we are going to check if the input data is valid. So this will make sure that your program is actually opening the file properly. So I'm going to copy and paste this code. Okay, there's not a lot different. The only thing we're adding is an if statement. And so what an if statement is it checks a Boolean expression. If the Boolean expression is true, the code inside of this if statement will run. If it is false, it will skip past the code inside of this statement and continue on with the program. So what this is doing is if not in data. And so what that's saying is if the input is not opened successfully, we'll say can't open the input file successfully, return 1. So this return 1 will end the program early. And then we do the same with the out data. If it can't open the output file successfully, we'll do return 2 and say can't open the output file successfully, ending your program early. So I'm going to show you, I'm going to leave my program as is, so I'll just run it as is, except I'll change the numbers just so you can see that it'll change the output file. We'll say 8.9. Okay, so I'm going to build it. So what should happen is this program should run with no problems because my input file.txt matches this. Okay, so let's do build. start without debugging. Press any key to continue. This is asking if you want to save any changes that happen to your output file.txt. You want to say yes. So we click on output file.txt, and now it's 8.9, 7.7, 6.6, 5.5. Great, awesome. But I want to show you how this actually works. This will help you find any mistakes you made in your program. Say you have all this, but your output file still has nothing inside of it. Well, if you have all this and you go and you erase this, so let's say I'm trying to open a text file. It's called input.txt, but my file is called inputfile.txt. Deep debug, start with debugging. As you can see, it says can't open the input file successfully. So that means my program ended early because I wasn't opening this successfully. Now, I want to show that there are a couple, there's a reason why, another reason why your program might not open it successfully. So let's say I call this inputfile.txt. And I want to show you another reason why this program might not work, why it might fail even though you have an inputfile.txt and you have it spelled exactly the same. I'm going to go into my projects. I named this project week 4. And as you can see, I have my input file right here. But if I were to move it out one file, so it's not in the same folder anymore, alright, it's in a different folder now, okay? It's in the folder previous. It's not inside of my project anymore. But you can still see that it's in my Visual Studio, right? So if I go build, debug, start with the debugging. As you can see, it says it can't open the input file successfully. And that's because the computer doesn't know where to look to find your file. So you have to make sure that your file that you're trying to open is inside of your project. Alright, so you have to make sure that this input file is actually inside of your project. It can't be outside of it or before it. You want it to be inside of the same folder as this VCX project or your .sln file as well. If you don't, then it won't be able to open your input file successfully. Okay. Finally, we're going to look at string functions. So these are functions that are specific to string. So we're going to just go through this. So this is one way to declare a string. We just say string str1. Excellent. Just to clarify though, a C++ has a string class. Some functions are defined in the class for strings to use. In C++ programming, you can declare string variables, objects. A string may be declared with or without an initial value. If you do not indicate the initial value is an empty string, 0 length, no characters. Here are some examples to help you understand C++ strings. Okay. So here we can just declare a string. There's nothing inside of it. We just call it str1, but we don't store anything inside of it. Here we create a string called to and then initialize it right away by saying equals hello there. Another way we can initialize it is using these round brackets and putting our string inside of it. As you can see though, when we're initializing it, we're doing these double quotation marks. We need these double quotation marks to say this is a string. If we did single quotation marks, then it would be a character, which is not what we want. Another way we can initialize a string is by making it equal to another string. So we can say string 4 equals string 2, and then we can say string 5 equals string 2 plus string 3. So what we'll do is say hello there and goodbye. String 6 equals A, B, C, D, E, F, G, H, I, J, K, L. And then we want to make it so that string 7 is only C, D, E, F, G. So what we're going to do is we're going to make it a substring, or grab just a substring of string 6. So what we do is you say string 7, round bracket, string 6. So this is the string that we want a part of. We say start at character 2 and grab a length of 5. So character 2 is C, because when we're doing this, we're starting at 0. We go 0, 1, 2, 1, 2, 3, 4, 5. Alright? Something you learn about later is arrays, and we always start counting from 0 with those. So just when you're trying to do this and you want to grab a specific character, remember to start from 0. So the dot length and size function both do the same thing. So we say string 8 equals hello. This size type is a special type of return. It's an unsigned integer. That's all it is. It's just an unsigned integer. So if we say string size type len, then we're just saying that len is an unsigned integer. So we say len equals string.8.length. So if we do this, the length of string 8 will be stored into len, and if we try to print it out right away, it'll just be 5. If we do the same with size, it'll be 5 again, because string length and size do the same thing. You don't actually have to store the size into a variable, though. You can just output the size right away by just saying string 8.length. Then we have the find and substring functions. So the find function searches the string it is called on to the first occurrence of a particular substring. If the substring is found, find returns the position of the first character. If not, find returns a special value string, no position, NPOS. The first argument is the search string. If the string The first argument is the search substring. It is a string or string literal. And then the second argument is where to start searching. If an integer greater than or equal to 0, if you find it, leave it out. Find starts at 0. That was really hard for me to read. Okay, so we make two strings, string 16 and 17. We say A, B, C, D, E, F, G, H, I, and then D, E, F. So what we do is we say, we create a string size type position. So this is an unsigned int position. And we set it equal to string 16. And we say find string 17. So what should happen is it will print 3 when we try to print POS, because D starts in position 3. So we go 0, 1, 2, 3. And then we say, well, let's do search string 16.find string 17, 0. So let's find position 3 and then grab nothing after it. Alright, so we go 0, 1, 2, 3, and it's just going to print 3 again. Both of these are accomplishing the same thing. But if we say find string 17, 5, we're saying start at the start at the 5th position in the string. So we go 0, 1, 2, 3, 4, 5. So we're starting at F and then checking GHI. Well, since we started at the 5th position of the string, we skipped over DEF, and we didn't find the word that we're looking for. So what it'll do is return a really big number, which is basically saying the string was not found. So we could look to see if we can't find a string if we do POS equals string 16.find AB. If POS is equal to string and position, then we know it's not found. This will be it's like our way of checking the error code. And then the substring function is like us cutting out a smaller string out of a bigger string. So we're just grabbing one specific part of that bigger string out and storing it into a smaller string. So the first parameter is the start position, and then the other is the length of the substring. But if you don't put the second parameter, you'll just grab the rest of the sentence. So if I say string 18 equals this ABCD F G H I, and then I say string 19 equals string 18 dot substring 52. So I'm saying start at the 5th character, grab 2 characters. So I'm going to go 0, 1, 2, 3, 4, 5, and then grab 2. So it's going to grab FG. So and then FG will be stored inside of string 19. And then we'll do string 20 equals string 18 dot substring 5. So we're going to go to the 5th character, F, and then we'll grab the rest of the string FGHI and store it inside of string 20. Okay, that's the difference between those two. So I know what you're thinking, well, that seems like a pretty inefficient way to find what you're looking for. But the idea is that you can use the substring function and the find function together to look for the position of a word that you want to cut out of a string. Alright, I want you to keep that in mind as you're going through your exercises. Alright, you can use the substring function and the find function to look for a certain string and then get rid of it. So this is just showing what operators work. So you can do the equal operator without any problems. You can do the plus operator. Alright, so you can say string plus string 2. Hello there. you know, and then somebody should be like, General Kenobi. No. Anyways, and then you can also do plus equals. So if we say string 1 equals hello, and then string 1 plus equals there, it'll say, that makes string 1 equal to hello there. Alrighty then. So that is strings, input file, input output, and then checking the input output state. That is all you need to know. If you need to go back and review anything, feel free to just skip around the video. And I hope you all have an excellent day.